Let's continue with the next video. So after we have B, so we continue with D. So we know A, we know the inlet from the well. So some of them become water here, some of them going inside the dehydrator. And then after that, so how does it work? So the water acidic is 7 because that's the requirement. With the glycol pickup is 3 gallon per pound mass. So this glycol pickup means that the glycol is able to pick up the water as much as 3 gallon per pound mass. So the water which has to be picked up is water content enter dehydration minus water content specification. Remember that the water content going into the dehydration is 110, and then the requirement is only 7, so we have to get rid of 103.65 pound mass per million standard cubic feet. So this one has to be picked up by the glycol. So the mass is just multiplied by the flow rate. So this one so this one is D. With one we get rid of this D. So this one we get rid of the D coming up here. So actually the D is the rich the water that going down there, plus plus the one that we injected here. So plus the glycol injection. So basically the glycol injection is just the water content to be picked up. This is glycol injection, water content to be picked up. So 103 multiplied by flow rate, so we have a pound mass per day, and then glycol pick up, which is 3 only. Okay, so we end up with the thing divided by 24 and 60 because from day, so we end up with the thing 4.21 GPM gallon per minute. Okay, so basically water rate from the dehydration multiplied by this gallon per minute, so we end up with the thing gallon per day and divided by 24 divided by 60, we have 421 gallon per minute. So if we have a schematic something like this, let us reduce the size a little bit. Okay, A is coming from the reservoir, okay, and C is the one because of lower pressure and temperature from 4000 to 1000, 320 to 120, so we end up with having much less water in it. So the rest of it, so 31 minus 2.1, 29 is jump outside from the scrubber. And then from this one we have to make from 110 to become 7. 7 is our requirement. So in order to do that, we have to inject 421 GPM of glycol, and then we end up with the thing. This one go out to the glycol recovery there, plus this one. So D plus E going up here. So the rest so become a lean, nice, not only in the small water content of gas. That's it. So This is I will give you a homework probably late tonight, and then to be submitted next week. And uh, I would like to adding up a little bit before we finish with this video number 5. We go to glycol, which is 2020. Okay, so it's not 2020. 20. What is the 2030? Okay, 2030. So in this 2030, so there are a lot of things, a lot of glycol. So what you mentioned about TEG is tetraethylene glycol. That's a TEG, the one that mentioned in here. TEG. Mentioned in here, TEG is that one. So if you see what type of glycol, so gas dehydration, so you have DEG, TEG, TREG, so triethylene and then tetraethylene glycol, diethylene glycol. TEG is the most common for natural gas dehydration. So I would like you to read this dehydration, understand it. So I might giving you this small detail of the dehydration on the exam. In this what you call it example here is including the size of the glycol dehydrated nutrition. Okay, thank you for your attention. Thank you for attention. Assalamualaikum warahmatullahi wabarakatuh.